let's try to prove this statement involving congruence mod 4 of any integer, okay? So remember, when you're trying to prove a statement about any number n, you can't just show it works for 1 or 2, right? But we might be able to better understand this particular setup if we do look at a couple possibilities. So let's just look at some integers and what we get. If n is equal to, let's say 3, well, n squared then would be 9. Well, 9 mod 4 is 1. Let's try another number. N equals 5. Okay, n squared then is 25. 25 mod 4 is 1. Ah, look. Both of the odd ones gave me 1. Let's see what happens with even. N equals 2. Well then, n squared is going to equal 4. 4 mod 4 is 0. Okay, so we get this piece, right? Let's try another even just to make sure we found the right pattern. N equals 6. 6 squared is equal to 36. 36 mod 4, well, 36 is 4 times 9, so that's 0, right? So look, I think that we have a pattern, and maybe the pattern, can you guys see, it's dependent upon whether the integer is even or odd. So we're going to do a proof by cases here. Consider what happens when n is odd, consider what happens when n is even, and then we're going to be able to draw out this conclusion here. So let's just write a sketch and then we'll write it up formally. All right, so we'll have case 1, n odd. Okay, so if n is odd, n is equal to 2k plus 1 for some integer k. Okay. And then we're trying to conclude something about n squared, so let's see what n squared is. Hopefully y'all know how to expand this binomial now. Be very careful, right? You've got more than 2 terms, definitely, okay? Now look, 4k squared is congruent to 0 mod 4 because it's a multiple of 4, and 4k is congruent to 0 mod 4. So we can replace, since we're under the same mod, right? We're under the same mod, so we can replace these equivalencies here. So let's kind of step back. We're trying to show that n squared is congruent to something mod 4, right? So far we know that n squared can be rewritten in this way if it is odd. So let's just write out that congruence. So if I'm just replacing with n with something that it's congruent to, then I don't have to worry about what mod I'm working in. I'm just rewriting n under no mod, right? I can put that into this new mod. All right, so based on this work, we have that n squared is equal to 4k squared plus 4k plus 1. Okay, and then using these substitutions, right, then n squared is congruent to 0 plus 1 mod 4. And we'll have that piece done. So then we showed we're trying to conclude that it's congruent to 0 or 1. So then since we've concluded that it's congruent to 1 when n is odd, then we've done our piece for that particular case. Let's look at the second case, n even. If n is even, then n is equal to 2 times some integer. Okay, then let's look at n squared. N squared is going to be 2k squared. That's going to be 4k squared. That's a multiple of 4. It's congruent to 0. So we'd write that out under the congruence mod 4. So I'd say n squared is congruent to 2k squared mod 4. N squared is congruent to 4k squared mod 4. And then I could say 4k squared is congruent to 0 mod 4, since it's a multiple of 4. So we have that n squared is congruent to 0 mod 4. All right, so now I'm just going to try to write this up in a way that makes sense. So we're good, right? We have a conclusion that we wanted to get to, right? We wanted to conclude for both these cases we either had 0 or 1, and that's what we got. So we're good. Let's write it up in a way that makes sense, hopefully. So let's start our proof. Declare that my sketch is over. Now I'm starting a proof. This is what I want you to read, okay? So we're going to let n be an integer. Okay. Then n is either even or odd. So let's just say case 1. Suppose n is even. Then, by definition of even integers, n is equal to 2k for some integer k. Also, n squared is equal to 4k squared. So, since n squared is equal to 4k squared, n squared is congruent to 4k squared mod 4. Let's see. I'm trying to think how to say it next. 4, well, usually you don't start a sentence with a number. In addition, 4k squared is a multiple of 4. So 4k squared is congruent to 0 mod 4. If n squared is congruent to 4k squared mod 4, and 4k squared is congruent to 0 mod 4, then n squared is congruent to 0 mod 4 when n is even. All right, let's look at case 2 now. Case 2. Suppose n is odd. Then, by definition of odd integers, n is equal to 2k plus 1 for some integer k. Notice n squared is equal to 2k plus 1 squared is equal to 4k squared plus 4k plus 1. Okay. So, we have combining the following congruences. N squared congruent to 4k squared plus 4k plus 1 mod 4. 4k squared is congruent to 0 mod 4. 4k, just 4k, is congruent to 0 mod 4. Okay. We conclude n squared is congruent to 0, oops, 1, right? 1 mod 4 when n is odd. Okay, that's the end of the case. Let's wrap up with a sentence here. Thus, for any integer n, n squared is congruent to 0 or 1 mod 4. QED!